Hey there, fellow retro tech enthusiasts. It's Vicky here, and today we're going to take a deep dive into a program written in QBasic. QBasic is an evolution of the BASIC interpreter that was built into many business and personal computers from the late 70s through the mid-80s. While not the most powerful or versatile of languages, it does maintain a modicum of respect as the great-great-great-grandfather of many languages today. The program we're reviewing today is a simple program called Silly Fortune Teller, which prompts the user for an input and provides a pre-programmed fortune. There wasn't a lot of computing power available back when this kind of program would have been made, so its output is, let's say, a little static. Let's start with the first line, as the program would anyway. This little cryptic term, CLS, is actually an abbreviated command that stands for clear screen. So, by having this at the start of our program, we begin with a blank slate, so to speak. The next couple of lines, starting with the command print, simply just prints something to the screen. These two examples are the most basic example of what this command does. The first one simply prints the sentence, "Welcome to the Silly Fortune Teller," on the screen. You'll see later that a semicolon can be added at the end of a print statement to either concatenate other strings or even prevent a new line from being written. In this case, a new line automatically follows this statement. Following this title is a decorative row of hyphens, sort of to act as a horizontal line. The fourth line here, you'll see our print command sitting on its own. This is pretty simple, it just prints a blank line on the screen as to add a little space under our horizontal line. The next few lines, which start with the command, input, does what you might think it does. It requests input from the user. These questions ask for the user's name, favorite color, and favorite animal. After the prompt, you'll see a semicolon and a variable. The variable is determined to be a string as it is suffixed with a $sign. The semicolon, which we will circle back to later in the video, does provide an indication to the user that their input is required. After the user answers these questions, it will move forward in the program. The next section of code is to simulate that the computer is working. Again, we see a standalone print to create a blank line, then some text printed on the screen. After that, we have what's called a for loop. This specific for loop initializes the variable I, starting with the value of 1 and continues to loop until it reaches the set maximum value of 5, as is determined in the line for I equals 1 to 5. The interpreter will execute any code that is in the loop, so, in this case, is the next two lines. The end of this loop is identified by the line that says next high. When that line is hit, it will return back to the beginning of the loop. If the maximum value has been reached, the interpreter will exit the loop and continue in the code. Otherwise, it will execute the code in the loop again. The code in the loop should be halfway apparent to what is being done. We know the print command now. In this case, it is simply printing a dot. The semicolon at the end tells the interpreter to not print it on a new line. Following print is a new command, sleep, which suspends program's execution for the set duration of time. In this case, it will suspend execution for 1 second. All in all, this should print 5 dots on the screen at an interval of 1 second per dot. After the loop is completed, we can see that it simply prints some more text to the screen. In fact, you see several print commands in a row after this block, but they're a little more complex than what we're used to. As you can guess, first we print a blank line. Next, we see the print command, but it's broken up. It prints the username, followed with a semicolon, then prints a long string of text that starts the pre-programmed prediction. That ends with a semicolon, and it prints their favorite color, then a space, then the favorite animal, then an exclamation point. The purpose of the way this is written is to concatenate all of these different strings into one line on the screen, without making the program hard to read. This is what the program would look like if we didn't concatenate like this. While functionally speaking, this is the same, it makes the code a little harder to read and troubleshoot, if needed. That's my own opinion. As we've talked about print almost excessively now, we're going to just skip past the remaining print statements until we get to the next unfamiliar one. In this program, that would be the do, as part of a do loop. While this is similar to the for loop earlier in the program, this one is a little different. The for loop will loop for a specified number of times, a do loop will loop either while, or until, a certain condition is true. In this case, We are looping while end key is blank. A do loop starts at the do command and loops all of the code within the block until it finds the next corresponding loop command, which returns the code to the do while, or until, the specified conditions are true. Here is another new command, end key. This is a special variable that is used to read a single character from the keyboard. If there is no key currently being pressed, it will return a null, or empty, string variable. You can use it to wait for a specific key on the keyboard, such as if you were building a game and wanting a specific input, or, such as in our case, you can wait until any key is pressed. Our do loop will run indefinitely until a key is pressed. Finally, we get to the last command in the program, end. This does what you would expect, it ends the execution. We can put this command anywhere in the program, and it will just stop there. That is how this program is structured. How about we run it and see what happens? By pressing F5 in QBasic, it will start the execution of the program. As you can see, it clears the screen and inputs all of the text we instructed it to. Now it's asking for our name, so I'll just type Vicky. Now, my favorite color is purple. And for my favorite animal, I really like alligators, because you always see them later. Alright, now it's thinking. As you can see, it's printing 5 dots, 1 per second. And it's done. It now gives me time to read my amazing fortune, and I'm just so happy that a purple alligator will somehow make me a new friend. I'm interested to see how that plays out. Now it's just sitting here, that's because it's waiting for my input. So, I'll press any key on the keyboard and poof. The program is over. Now that that's all done, did you see the bugs? The great thing about a computer is that they do exactly what you tell them to do. But sometimes what you tell them to do isn't exactly what you wanted. In QBasic, I can jump back and forth between the code and the output by pressing the F4 key. So, using this tool, let's look at the inputs. Do you see the double question marks? This is from the semicolon at the end of the input statements. We have two options here. We can remove our question mark and space, which will remove the one, but I personally would prefer to be in complete control of our output, so let's go with option number 2, let's replace the semicolons with commas. This provides the same result, but tells QBasic not to add the question mark and space at the end. Running the program again, by pressing F5 again, we'll start from the beginning of the program. As you can see, the question marks are no longer doubled up. So let's provide the same answers again. My name is Vicky. My favorite color is purple. And my favorite animal is an alligator. Now it's thinking again and, again, same result. But I still see one more bug in my code. It's while the computer is thinking. See how the dots go to a new line? Let's fix that so it just adds dots to the same line as the let me think text. This is a simple fix, we just add the semicolon to the end of the print statement. Let's run it one last time, Vicky. Purple. Alligator. And, voila! Our perfect program is perfectly running. That's all I had for you today. I'd love to keep making these kind of videos and just showing off old software and explaining, or even learning, how it works. If there's any content you'd like to see, comment below. Don't forget to like and subscribe. See ya!